Hey everybody, good morning.
Good morning.
How are you all doing today? I hope you're having a good Saturday. Uh, any day with robots on it, it's a good day. So we will go from there. So welcome to this morning's FTC Clinic. This one is going to be focusing on Onshape CAD. A few weeks ago on one of the Thursday night clinics, for a couple of them, I did a demonstration of Fusion 360 in for just to show how to design and build a robot in Fusion 360. But Onshape is another up and coming CAD package that I know a lot of people are interested in. So I thought I would also reprise that presentation, but using Onshape CAD instead of Fusion 360. And this would be my chance to learn Onshape CAD. So I'm going to do that. And I'm going to get into it fairly quickly, I think, but I'm still getting my desktop set up here with all of the pieces that are needed. So give me just a second to get all of the different pieces that are here. I think it's this one. Let's see if I got that right. All right. So I'm just going to begin. I just have a few slides, a few notes that I would like to go through for this. As always, for these presentations, if you have a question, feel free to ask it either in the chat window, or you can just unmute yourself and interrupt me. And I will pause at a few points throughout the demonstration this morning to take questions from people, or you can raise your hand in the chat window as well. So, I like to do it interactive. I don't want to get too far ahead of people or things like that. Just a couple of reminders for the upcoming season. First in Texas grants are open, and we're only a couple of weeks away for the first round review closing. So definitely get your grant applications in so that you can be considered for the available grants. Last year, again, there was a lot of money left over towards the end of the year. So I don't know about a lot, but there was some. So we want to make sure that all of our teams are getting the support they need as they go through the season. And then secondly, if you haven't already done so, please be sure and sign up for the North Texas FTC Google group so that you can learn about upcoming events and any news that may be coming with respect to the upcoming season or other presentations that we'll be doing and things like that. So I would definitely look into that. Any questions before I get started with the Onshape stuff? I'm going to dive right into it pretty quickly here. And I have a hard stop today that we have to be done by noon because the first LEGO League kickoff starts at noon today. So I want to be sure and get to that. All right, well, not hearing any questions, I'll go ahead and just start into it real quickly. So again, Fusion 360 is a really good CAD package that many teams have been using for a while, but lately a lot of FTC and FRC teams have been looking into the possibility of Onshape CAD. And why would a team want to consider that over Fusion 360? Like Fusion 360, Onshape CAD is a cloud-based system which makes it easy to do collaboration between team members because the models are being stored not locally on local computers, but in the cloud on servers somewhere. And that makes it really easy to keep track of the models that are there. But two things that really set Onshape CAD apart from some of the others is, first of all, it's very easy to get to an extensive FTC parts library, and we're going to see that today. And secondly, it works on lots of different platforms. Because it's a cloud-based CAD system, unlike Fusion 360, what Fusion 360 does is it only works under Windows or a Macintosh. And Fusion 360, when you connect to it, it downloads some software to your local computer that does most of the CAD work. And so almost all of the CAD rendering and things are done locally on your local computer, and you need a reasonably fast computer to do that, to be able to make that happen. In Onshape CAD, the CAD is done in a browser. And the fact that it's done in a browser makes it really nice because Now it's available and you can actually do the CAD from things including Chromebooks and tablets. Today I'm going to be doing it from my Linux desktop, which is a nice way to do CAD there. So I'm really pleased to be able to do some reasonably good CAD now from my Linux desktop, and know that it's also available for Windows and things like that. So that's another really good feature of Onshape CAD. So for students who might not have good enough workstations to be able to run Fusion 360, or you may have limitations in terms of licensing and things like that, Onshape CAD looks to be a reasonably good alternative. And as with Fusion 360, if you are an educator or you are on a FIRST robotics team, then you can get a educational license that gets you access to a lot of the features that you'll need for free. So the educational licensing program looks pretty good there as well. Before I go into Onshape CAD, well, actually, let me let me see. Let me just target where we're headed for this today. Let me stop sharing this screen, and I'm going to share as soon as I find it. Let's see here. I'm going to share a video real quick. So share that. All right, and so this is what we're going to aim for designing today. And I'll just play it. Oops, you know what? I bet I did the sharing wrong. Just a minute. Let me restart that again. I did. All right, share. Let me mute this so that we don't get that. All right, so this is what I'm planning to design today. So this is a little Mechanum drive robot that I built over the summer. And my goal for this robot was to create a Mechanum drive base that was in the style of the way my team 7172 does their driving bases, but used almost entirely Rev parts. I wanted it to be completely Rev Robotics parts with minimizing the number of non-Rev Robotics parts and components that would be needed and the amount of 3D printing that might be done. So this robot is, as you can see, it's a Mechanum drive, so it's able to drive forwards, backwards, sideways. It's able to turn and do all the things you would expect with Mechanum wheels. It's reasonably speedy and can do some nice things. So that was my goal for that design, and I started by designing it in Fusion 360, and so now we're going to repeat that design in Onshape CAD. All right, so let's go and look at Onshape CAD, and I'm going to show some basic operations and some, let me get my things here. I'm going to show some basic operations in Onshape CAD, talk about the parts library, and then we'll get into designing the robot. We'll go for as long as we can today. If you need to leave, I am recording this session, so be sure you know that you'll be able to come back and view the contents later. And it'll be up on YouTube for people to see. So, if you need to drop out, that's fine. And yeah, well, let's just get started. So I'm going to go back to sharing my screen, and I'm going to go to this one here. And I'm not going to optimize for sharing that. All right, so now we're back on my slides. So I'm just going to open up a new browser window and go directly to onshape.com. And like most other websites, there's their homepage and they have a button for signing in. So I'm going to go ahead and sign in with my my username. Oh, I'm already signed in. How about that? So I didn't have to type my username and password because I signed in a little bit earlier, and it still remembers me. So when you enter Onshape CAD, this is the interface that you get, and you can see that it has a list of folders that are in my workspace that have been there. A lot of these folders contain parts that came from the FTC parts library, pre-populated, and we'll look and see what are in those different parts. These are the latest projects that I was working on or looking at, and I can create new documents. Anything that you do in Onshape tends to be a document or a folder. So a document would be like a project, a design that you're working on, and a folder is a place where you can store documents and other folders. So that part's pretty easy. I should also note at the outset, I would not consider myself an Onshape expert. I literally learned it this week. So I'm still learning things, and there may be places where I run into some difficulties, or just are figuring out things as we go. So if you encounter that or see that, just know that I'm kind of new at this as well. I just wanted to see what it could do and share that with others. In addition to what's in the My Onshape part, which is kind of your home dashboard, you can just go and see things that you've created or uploaded, things that have been shared with you. So far, I haven't had anything shared with me. Any teams that you're a part of. So I signed up and asked to be part of the FTC Robotics Parts team, which is a group. It's a library of FTC parts being maintained by several well-known FTC teams, and they work on curating this library so that it has parts available, so you don't have to go find all of the parts that are there, primarily led by FTC 2901. There's a lot of public examples that can be looked at of things if you want to explore what can be done in Onshape CAD. And so there's just a lot of pieces that are there. So I'm going to go back to my dashboard, and I'm going to start by creating a new folder. And this is going to be 0919 Onshape demo. And so I've just created that new folder, and I'll go into that folder. And the two things that I want to focus on to begin with are the way that you create assemblies and the way that you get access to the library of parts, because those are the basic operations that you need to know to be able to start designing a robot in Onshape CAD. There's some other operations like how do you create your own parts, but I'm just going to start with how you create assemblies. So I'm going to start by creating a new document, and the name of this document is going to be an example assembly. Actually, I'm just going to say an example design here. And it takes me into the CAD part, which is where we can begin creating our robot design. Just to talk a little bit about the interface that's here, on the left are the features and parts that will be used in the design. Across the top is your toolbar with all the many different CAD operations that can be performed. In the middle of the screen is your design workspace. And right now you can see that it's showing 3 planes that we can be working in. So we have top, front, right. And using the mouse, by holding down the right button, I can rotate the view that I'm looking at on my model. There's the view cube that's up in the upper right-hand side. And so if I click on top, it's going to let me look at the top view of the model. If I click on one of the corners, it gives me an isometric view from that corner. If I click on an edge, then I can look at different edges and do different types of motion that are there to be able to look at the model in different ways. So you'll see me navigating that throughout the day today, especially doing the corners and the like. It's also possible for you to create custom views. So there's a lot of different options here for creating your own views that you can quickly get to of your model. Along the bottom is where you create the different components that you're going to need to design your robot. And components are divided up into 2 different types. One of them is called a part studio, and that's where you're designing your own component by doing extrusions and basically starting from raw materials. And then there are assemblies. And an assembly is where you're taking a variety of parts, either that you've designed yourself or that you've obtained from other sources or even other assemblies, and put them together to make whatever device it is that you want to do. So I'm going to start with an assembly because that's what we will typically do to create our robot. And so here I am, and now I have this blank thing, and the little dot in the middle of the screen is called the origin. And that's the 0 point for the CAD model. And what I'm going to do is just assemble a simple wheel and bearing combination using Rev parts. So let me go and do insert. And when I go through and say insert in my current document, I haven't created any parts yet. So it says no part studios available, and that's fine. I'm going to go to other documents. And in other documents, I now have the option of being able to access that robotics parts section that has all the different robotics parts. And so I'll click on it, and it brings up a list of the different vendors with robotics parts that that have been collected and curated by the group that's creating those. And so
How do you get to that?
you have to send an email to them. It's first at pcc.com, I think. And in the invitations that I sent out for this meeting, and I'll post it as well. There's a document that describes all the steps that you need to do.
I missed it. Sorry.
That's fine. Let me see if I can find that real quick. So let's do groups.google forum at North Texas FTC, and it's in the Onshape one that I did here, and it is. Oh, did I not post it there? I didn't post it there. Oh wait. Oh, I didn't post it there. Well, it's in the Roboplex page. I thought I had posted it in the other thing. So here's the clinic, here's today's event, and here's the thing. Oh, of course, it's not working right now. Anyway, there's a Onshape for First Teams document that really describes how to get signed up with Onshape and how to get connected to that library. I'll make sure that that goes out as a separate message to the Google group. All right, so let me get back to, sure, of course. Thanks for pointing out that I had not actually done that. That was oversight on my part. So you won't have it by default. It doesn't come with Onshape. I'm going to go into the Rev Robotics folder. Within each vendor, they're organizing the set of parts by the way they're organized on the vendor's website. So if you go to Rev, then Rev has separate sections for FTC and FRC. So I'll go to FTC. And then in the FTC section on the Rev website, Rev breaks it down into structure, motion, kits, hardware tools, game elements, things like that. I'm going to go to structure because I want to start with a piece of extrusion. And I'm going to just grab a piece of extrusion that is, let's see if I can find it or not. I don't remember the numbers. You can see that on the as they're putting it together, some of them they haven't renamed yet. So you would need to know the Rev part number to be able to use it. Actually, I'll just grab a 1 meter piece of extrusion to start with. And it won't let me grab it. Oh, all right, then I won't do it that way. I'll do the configurable length extrusion. One of the nice things about the parts library is that the parts that come in for a piece of extrusion where it may be available in multiple lengths and you may need to cut it to length, they have it set up so that you can create them on the fly in the lengths you need. So I'm going to grab extrusion here, and it will bring up this dialog box, and in there I can say how long I want it to be. So I'm going to ask for a 100 millimeter piece of extrusion. And I'll just enter that, and it comes up and it grabs and creates a 100 millimeter piece of extrusion for me. And if I click that, then you'll see it puts it in my workspace. When it's in the workspace, I can actually drag this around to place it wherever I want. Or what they often recommend is to simply click the checkbox and it will automatically place the new part at the origin. So I've now placed this piece of extrusion into my workspace. It's 100 millimeters long. Here's the origin that we can see. And I can start working with it in many different ways to do things. So I'm just doing a simple bearing joint to begin with. So the next thing that I'll need to do is to grab a pillow block from the Rev folder and attach it to this extrusion. So I'm going to go back to Insert, Other Documents, into the Robotics Parts folder, into the Rev Robotics folder, FTC. The pillow blocks are in the Motion subfolder on the Rev's website. And then In that, you have a choice of rotary motion, motors and servos, or linear motion. Since this is for a wheel bearing, it's in the rotary motion. And I'm looking for bearings and shafts. And the piece that I need is the pillow block, which is this one here. And so I'm going to add that into my model. And so it's now loaded that into the model as well. The basic operation that we want to do in CAD when we're designing from pre-built parts, in Onshape it's called a mate, M-A-T-E, mate. In Fusion 360 they're called joints, but in Onshape they're called mates. And so what we want to do is to mate these two parts together as if they were being assembled in real life. So to do the mate, first of all, mating things or joining things in a CAD package with Rev extrusion can be a real challenge, because normally when you're mating things, if you were using Tetrix or if you were using Actibotix or one of those other things, you just line up the screw holes and you join them together at the screw holes, and then that's where a screw would go through. But when you're looking at extrusion, there's not a screw hole that you can attach it to because you're using a slot, and you really want to make sure that your parts are centered properly. So I'm going to go through the process that I found in Fusion 360 and in Onshape to attach things to extrusion, things that have screw holes, to put them on the extrusion. If you're not familiar with how Rev extrusion works, generally what happens is you have a screw and a nut and the parts you're trying to join. You put the head of the screw in this little slot so that the threads are sticking out. And then you can place the part that you're wanting to attach to it over the screw threads and then put a nut on top to tighten it down. And that gives you a good rigid connection to be able to hold it in place while still being able to select anywhere along the slot where you want it to be attached. So the way I've found, and perhaps others have seen better ways to do these attachments, but this is the way that I tend to use. Across the top are the different types of activities we can do when we're working in an assembly. The first set are the ones you use most common, and these are the different types of mates. So the first one is called a fastened mate. That's if you have two parts that you want to join together that won't move, that they're rigid with respect to each other or stuck together. There's also a revolute mate if you have something that spins, a slider mate for things that slide, and a bunch of other mates that I'm not going to go through all of them at this time. And I'll just introduce the tools as we need them in this process. So I'm going to say I want to do a fastened mate. And now it's over here on the left, it says you're starting to do a fastened mate. Fastened means two rigid parts put together. And now I have to select what I want to join. And I've found that the easy way for me is to join this circle that's right there, which is where the screw hole would go. I like that circle because it's on the surface that will be up against the extrusion, and it's pretty easy to find, and it's pretty easy to attach. Now, when you're finding these different places to do your mates, you want to make sure that you get the exact point you're looking for. So if I highlight this face, and let's see if I can get this face to highlight. There we go. So I'm highlighting that whole bottom face. You can see all of these different possible mate points that could be used to attach things together, including the center of that circle. So I could choose that. In order to get to the center of the circle, if I just try and move my mouse over there, then I kind of lose the reference to that face. So the way to do it is when you have something highlighted that has the join point that you want, if you hold down your shift key, so right now I'm holding down my shift key, you can't see it, it'll lock the selection to whatever you have highlighted, and now I can move my point around to go and grab whatever part of the model I really want to grab. So I'm going to grab that little point there, and so it highlights, and over here it says I'm going to join this connector of that part. And on the other side, I want to join it to a place on the Rev extrusion. And what I found is the easiest thing to do for me is, and there I just got lost, so I'm going to go that. What I found is the easiest place to join for me is to join to this inside face of this extrusion, that one there. For that face, there are 9 points that you can join at, 3 on each end and then 3 in the middle. So I'm going to join with this point here, which is right on that face and right in the middle at the edge of the extrusion. And so I'll click that little point. I could go for the corners. I could go into the middle of the extrusion, but I'm going to click this point here, and it brings these 2 points together, joined at those 2 points that I selected. Now, when I do that, you can kind of see that, you know, it's put the pillow block right in the middle of the extrusion, and obviously that's not what we physically want. So we're going to move this around a little bit. First of all, I'm going to flip it over. So there's an arrow here, and I'm going to say flip the primary axis, and that's going to flip the pillow block over. And I can do it again to flip it back. So I can easily flip that piece to be where it needs to go. Secondly, I want to get it so it's not pointing, it's not intersecting the extrusion. So I'm going to change the Z-axis, and that's done by using an offset. So up here in the fastening thing, I'm still working on the fasten. I can click offset, and now I can change the offset that I want to use between the 2 mating points. By default, it starts at 0, 0, 0. I'm going to change the Z distance between them, which is the vertical distance between them. And I'm going to change that to be 5.5 millimeters. Now, how do I know that it's 5.5 millimeters? Because I've done it a few times, but I'll show you how you can find out yourself in a second. So I'm going to say 5.5 millimeters. And now we can see that this pillow block is resting on the surface of the extrusion, which is what it would really do in real life. I want to rotate it by 90 degrees so that it's along the slot and not perpendicular to it. So this little button here lets me rotate that pillow block so that it's 90 degrees. Every time I press it, it moves it by 90 degrees. And now I want to move it so that it's not right on the edge of the extrusion, but it's somewhere more in the middle. So I'm going to try and zoom in real close to figure out which axis that is that I need to change. If it's X or Y, it's the X axis, which is that little red line that I don't know if you'll be able to see on yours. But that means I need to change the X value. And so I'm going to move it about 30 millimeters into the center of the extrusion. And now what we can see is that I've joined those 2 together, and I can just hit the checkbox to say, okay, make that happen. And now these 2 items move as a unit. They are fastened together by using that mate. So I'm going to pause for a second. Does anybody have questions about what I did there? Anything you'd like to see redone, either in the chat window or just turn on your microphone?
Yeah, Patrick, I have a question for you.
Yes.
Is it possible to set those up, like the positions as variables? So you could set up,
So I missed the last part of your question. I heard the first part, is it possible to set this up? But then you cut out after that.
Can you set them up with variables? So
yes, it is parametric.
Things move with one variable.
Yes, it is. It does have the ability to do parametric things. So you can do, in that place where I had offsets, you can put formulas in there. You can have variables that are specific to your model. You can do measurements relative to other things. I haven't personally done that yet because I've only been doing this for a couple of days, but I do know that it's possible to do that.
Okay. Thank you.
Any others? All right, so that's our first join. Oh, why was the Z value 5.5? By looking at the extrusion, and if you go look at the design docs for the extrusion, what I needed to do was to get the distance between this surface of the extrusion, this little flat part on bottom, and the top of the extrusion. And so I can actually just click each of those now that I'm not doing, if I say I'm not doing a fasten, I can actually just click each of those. So I'm going to say, click this one, and it selects that surface, and now select this other surface. And what it does is it comes back and tells me that the distance between those 2 surfaces is 5.5 millimeters. And you can see that down at the bottom right of my window. So that's how I knew the offset needed to be 5.5 millimeters. Now I knew that because I've done this for so long in Fusion 360 to just know what that is. But anytime you need to know a distance in Onshape, you can just click the two items that you need to know the distance from, and it will tell you the distance between those two items, whether it's surfaces or anything like that. And in fact, while we're here, let's just click on this end of the extrusion and zoom out, and we'll click on the other end of the extrusion, and we'll be able to confirm that we did get a piece of extrusion that was 100 millimeters long from doing the other thing. So it's really handy to be able to do that. Another thing that is common to just want to know is like if I need to know the diameter of the cylinder, then I can click that and it tells me that the diameter is 9.1 millimeters. Or if I need to know, and I haven't tried this one yet, so we're trying this for the first time for me with Onshape, I want to know the distance between that circle and that circle, and it tells me that the center to center distance for those two circles is 24 millimeters, which I know to be correct. So finding out distances in Onshape is really, in that way, it's actually kind of easier than what you need to do for Fusion 360, at least for what I've done so far. All right, so I'm gonna, we've done a simple join. Let's do a little bit more complex of a join. One thing I'm gonna do is I'm going to fix this model. Right now, these pieces are such that I can kind of move them around. I'm gonna fix it so that they're fixed in space. And I'm just gonna do that fairly quickly. We'll do it again when we get to doing the robot design. But I'm gonna click on that circle, and you'll see these little crosshairs pop up where I can move the part within my model using these three arrows. So I can click on an arrow and move it in a specific direction is one thing I can do. I can also click on an arrow to rotate it in a specific direction. So right now it's vertical. So if I look at my view cube on the right, you can see that top is facing that way. And so right now it's vertical. I'd really like it to be horizontal. So I'm going to grab this little circle and pull it around 90 degrees to make it horizontal. And so now it's horizontal, and I can set that as being the other thing. The last thing I'm going to do is I'm going to take this point and I'm going to move that to be the origin. So there's a lot of options here. All I did to get to this part was I right-clicked on this little center part that I've got. And when I go there, it says move to origin, and you'll see that the extrusion will move so that it is right there. That point is at the origin of the entire model. And so I can just click outside of that, and it's moved in that specific spot. Now I can right-click on the extrusion, and I can do fix. In Fusion 360, this is called ground. In Onshape, it's called fix. And what fix does is it says lock that part here so it can no longer be moved. And so now that I fixed it, if I try and grab it with my mouse, it won't let me actually move it anymore. And I can't move the pillow block either because it is fastened to the extrusion that won't move. So that's a quick thing to be able to do to make those parts easy to work with. So now we're going to add in the parts to get a wheel on here and to make it so that it can turn. So once I have a Rev pillow block, I need a Rev bearing, or what many of us would call a bushing. So I'll just go back to the parts folder, into the Rev Robotics folder, FTC motion, rotary motion, bearings and shafts, and follow until I find the through bore bearing. I want the full through bore bearing, that's this one, and add it into my model. And so here it is in my model. And I can just say, okay, I've got that. And now I want to mate this part, which is the through bore bearing, with this one. A lot of times the parts come in random colors. And so I'm going to very quickly see if I can change the appearance here. So I'm just going to grab this part and I'm going to right click and see if it lets me change the appearance or not. It might not let me because I don't own the part, and it appears that I can't do that. So I'll worry about doing that later. I imagine if I sent a note to the library maintainers and said, hey, can you make this black so it's easier to see in our model and looks more realistic, they would be able to do that. But we're going to go ahead and do a fasten. So this time I want to fasten this piece into this cylinder, into this hole of the pillow block. And again, it's one of those places where I have to think about what it means physically, because the CAD model doesn't necessarily know what that means. But I know as a as a designer that what's going to end up happening is that this surface, this underside of the bearing block, is going to be on the outside of the pillow block. This underside of the bearing is going to be on the outside of this. And so those are the two things I really want to fasten together. And this time, because I know it can spin inside of that hole, instead of using a fasten joint mate, I'm going to do a revolute. So I'll say, give me a revolute, and I'm going to grab that interface, and I've got my mouse like literally on the face. I could also grab this circle, I could also grab that circle, but if I grab the face, then I'm quite certain I'm going to get the right part. And I want it to mate with this part of this hole. In particular, I'm going to get it to mate with that section right there is the center of revolution that I want. So when I click it, it pulls those two together. It put it in there backwards, so I'm going to do a flip. And so now it's in there forward. And I can animate this. So now it's mated them together, right? We can see that it's inserted inside of the pillow block. And I can animate this by clicking the little animate button, and it's going to show me what kind of motion is available for that mate. And here it's able to revolve around in a circle around the center of the axis. And that's exactly what I want. So I can just hit OK, and now I've added that, that bearing into my pillow block. Any questions on that? Right, it's going to start to go fast from here, which is nice. Once you have the basics of how to mate parts together, then it becomes much quicker to design parts. You just have to learn some little tricks as we go. Okay, well, the next step is obviously let's put an axle in there. So I'll close that, and let's go back and grab out of the robotics parts from Rev Robotics, the FTC section, in the motion part, rotary motion. This will be bearings and shafts, and I'm going to go grab a, I'll grab a 135 millimeter hex shaft to pull into my model. And so it's done that, and I'll put it there. And now I can close this because I'm done. Oops, I accidentally hit the cancel button instead of the OK button. And Onshape is really nice about that. It's like, did you really mean to cancel that? And so I can say restore, and it puts it back in. So there is the axle that I just pulled in. For those who are familiar with Rev products, you know that they use 5 millimeter hex axles as their primary thing. And I want to insert this axle into this bearing. So it's another mate. And I'm going to do it as a fastened mate, because even though the axle will turn, the axle is fixed with respect to the bearing. So the bearing will do the turning, and the axle will simply turn with it. So I want to mate this end here with the hex part of the bearing there. And I'm going to go grab that little center point and mate them together. And there we go. They are mated together so that I have an axle there. Now I do need it to extend a little bit on both sides. So I'm going to go and change the offset. And on the Z offset, I'm going to move this out by about 30 millimeters. Just to get the axle to be out by about 30 millimeters. And now I'll say okay. And now that axle has been inserted into this bearing. And since the bearing can turn, the axle will turn with it. So let me turn off the fasten. You'll be able to see, I'm going to grab the bearing and turn the bearing. And when I do that, you can see that the axle turns with it, which is really, really nice to be able to see. And then, of course, the next thing that I would probably want to add is a wheel. So we'll just do one more example with a wheel. I'm going to insert, go to FTC Robotics Parts, go to Rev Robotics, FTC Motion, Rotary Motion, Wheels, and they have a lot of the different types of Rev wheels available. I'm going to grab their Ultra Traction wheel and pull it in. The wheel here you'll see is made up of several separate parts. And we know this to be true because the Rev Robotics wheels, they'll have like the tread around the side, and then they have the hub, and they're two different materials, and they're glued or attached together somehow. And so for this wheel, I really don't want to grab the separate parts if I can. I'd rather see if there's an already built assembly, and there is. And the assembly will bring in the entire wheel as an assembly so that hopefully the tread and the hub are already attached together. If not, we'll figure out how to fix that here in a second. So I've selected the wheel now, and Onshape is bringing it and figuring out what it needs to look like in my model. And I'm gonna just plop it in here and say, okay, I've got my wheel. And let's see what happens if I drag the wheel around. So I'm gonna grab the tread of the wheel, and we can see, oh, the tread is not attached to the hub. So we really wanna make sure that we have those two things attached together. So I'm gonna undo, and that brings the tread and the hub back together when they were pulled in. And that's because the files, when they came in and when the assembly was created, they didn't create a mate to mate those two things together. I can, of course, create a mate to mate those two items together, but there's also an option to just make them into a group. And so there's a group button that's here. So I'll just go select the wheel itself, and I'll explain what all has happened on the left here in just a second, but I'm gonna select that wheel part, and then I'll say make that into a group. And when I click the group button, confirm that I want to group those things, now all of these parts are treated as a group. So when I grab the tread, the hub comes with it and vice versa. Right? So sometimes if you grab parts and they're not actually connected to each other, then what you want to do is group them so that they are treated as a full group. What's been happening on the left is that all of the parts that I've been pulling into my model are showing up here in the assembly. And so here is assembly one, which is what I'm creating. And we started out by bringing in an extrusion, and then we brought in the pillow block, and then the bearing. Next, we brought in the hex shaft, and then finally the wheel. So all of those parts show up there. And then below it are all of the mating features that we've created. So here is the first fasten to fasten the pillow block to the extrusion, then the bearing to the pillow block, then the axle to the bearing, and then finally to group all of the wheels together. So these are our different components or different steps that have been used to create this assembly. So now I'm going to attach this wheel to my axle. Intuitively, one would think that the way you do that is to literally attach the wheel to the axle. But because, again, if I think about it a little bit, what I know is, or what I believe is going to happen in real life is that this face of the wheel is actually going to be up against the bearing. So I'm going to attach the wheel in the model to the bearing, and as opposed to being the axle itself. So that's, again, that's going to be a rigid joint, a fastened joint. And I'll select this face here, this little circle that I want right there in the middle as being the thing I want to fasten. And I'll go over to the bearing and I'll say I want to fasten it to the bearing at the middle. And it brings those two items together really quickly. And we can see, except for all the highlighting that's taking place, so I'm going to go ahead and clear this. We can see that the wheel has been attached to the bearing. And so because the bearing is also attached to the axle, it's attached to the axle. When I pulled it in, you can see that it's a little off. It's not rotationally correct, like the axle isn't turned correctly. And so if I need to fix that, I mean, at one level, I could say that's not important to the design, that those be mated. But we might want to make it so it looks proper. And so in the fasten joint that I just made, and there's not a way to do it as you're creating the fastening that I found. You have to do it in this separate step afterwards. I can expand out to the fasten joint, and the things that make out that last joint that connected these wheels together are these two mate connectors. The mate connectors are the points that were on the parts that were joined together, and I can edit those. So I'm going to edit those. And I'm going to do a move operation. And here's where I can kind of move the point. And the one that I really want is rotation angle. And so the wheel, when it came in, was rotated 30 degrees with respect to the axle that I want to do. So I'm going to just put in here, rotate it by 30 degrees. And when I hit tab, you'll see that it turns the wheel by 30 degrees. And now the hex shapes line up properly. And I can say, okay. And now it looks the way I want it to look to be able to do things. So the wheel is joined to the bearing, the axle is joined to the bearing is joined with a revolute joint to the pillow block. And so now I can actually see this wheel turning in my model. If I just grab it with my mouse, I can make it turn in different orientations to make sure that, to just be able to animate it and see how things will act together. When you get to some more of the advanced joints, or as you have things connected together, you'll be able to see the way that arms move or the way that things will come together depending on the linkages they have. And that's one of the really nice features of using a CAD system for this. Okay, so I'm going to pause for a second. Take questions, comments, anything from the group. Am I going too fast, too slow? I see some thumbs up in my video windows for those who are sharing videos, which are good. We do also have the ability to put marks in there. I see a couple of thumbs up in the participants window, so I will keep going. So I'm going to put this aside, and we're going to go to building the robot that I showed in the video, and to just talk about it for a little bit. Let me pull up that video again, and also just stop sharing the screen so you can see that I'm still here, and it's not just a disembodied voice talking to you. And let me go grab that video again while I am pulling this up. Because I had closed it a second ago because it was in my way. And we'll go back to Zoom. And let me share that screen. Here we go. And we'll just talk a little bit about the robot design. So here I've got the picture that's on. And again, what I wanted to do was to really make use of almost strictly Rev robotics parts. So nothing that wasn't Rev, to the extent that I could. I succeeded, except for the bearings don't come from Rev that I ended up using, and I'll explain why. And I needed a 3D printed piece for this, and I'll explain why for that. But the basic frame, this is a frame that 7172 developed for the after the relic recovery season in the summer off season, and we've used that for our team's driving frame ever since. And it's basically a U-shaped frame where you have some component across the back. In previous years, we just did a piece of Rev extrusion across the back, and then you have other Rev extrusions attached to it that go forward, and the wheels are then mounted between the pair of extrusions that are there. So you have a nice open section in the front for intakes and for bringing things into the interior of the robot. And you have a good structure for your wheels and so forth. Now, 7172, when they've done this model in the past, they would custom make plates to go on the ends to attach all of these together and make sure that they were parallel to each other where they needed to be parallel and perpendicular where they needed to be perpendicular. Since this last season, Rev has come out with their channel structure. C channel and U channel, and so I decided I would prototype using the C channel and U channel, and I have to say it works really well for this particular purpose. Since a lot of teams I know won't have the CNC mill or other cutting and milling tools that 7172 has available to them, I wanted to come up with a design that teams could build without having to do a lot of cutting of plastic or aluminum parts with custom drilling and things like that. And so the basic structure is going to be a C channel across the back, and then a pair of Rev extrusions going forward with some other C channel on the front, and then mounts for the wheels. So that's the basic structure that I'm kind of looking at for doing this. So let's go back to Onshape, which is here. All right. And I'm going to leave this one and go back to just Onshape, back to my dashboard. And here we can see I did example design. So I'm going to create a new document. And this is going to be Rev Mechanum Drive. And I'm just going to start a whole new design here for the Mechanum Drive. All right, so we're back at the beginning part of Onshape, where I've got this empty part studio where I can design a new part, or I'm going to go straight into an assembly and start creating my assembly. And I'm just going to start pulling pieces in. So I'm going to grab the channel that's going to go across the back. And so I'll go to other documents again, robotics parts users, Rev Robotics, FTC, structure, channel. And here is the channel that has been recently made available by Rev. And I'm going to go down and find a piece of C channel. And I have my font made bigger so that hopefully it's easier to see in the broadcast today. So some of the labels get cut off. I'm going to grab this 408 millimeter piece of C channel as being my primary piece of channel. So I'll just click it and say, grab that piece of channel and bring it into my model. And then I'm just going to hit OK. And so it should be reasonably well centered somewhere on the, nope, it's not. So here's the origin way out here. Rev's models don't always put the parts right at the origin. And I would like to go ahead and move this piece of channel to represent the actual orientation that's going to be on the robot. So I'm going to move the channel to be at the origin, where the center of the channel is at the origin. So all I have to do is go in here, click this little circle, and it gives me the thing that I can use to kind of move things around. And I'm going to make sure that that's right on the center of the circle. And it did snap into place, just in case you were curious. And now I'm going to right click that and say move that point to the origin. So now my channel's on the origin. And I'm going to try and get it oriented with respect to my robot. So I definitely want it to be flat. So I'm going to turn it 90 degrees to make it flat. And right now this channel is parallel to the left side of the robot. I really want it to be parallel to the front or the back. So I'm going to turn it 90 degrees in the other direction to get it to be able to act as the back of my robot. And then I'll hit OK. And now we can see that that channel, when I'm looking at the back of the robot, then what I have is the channel that's there. Oops, I may not have grabbed the center hole, but I'm not going to worry about that for now. I can change it later. And once I have that channel where I want it to start, I'm going to fix it in place. So I'm just going to right click on it and hit fix. And so now it's stuck there at the origin and won't move around. So that's the back piece of my robot. Next, I'm going to attach a piece of extrusion. And attaching the extrusion here is kind of tricky, the same way it was when we were attaching the pillow block to the extrusion, because you've got to kind of figure out where you want it to go for attaching the extrusion. I'm going to attach my extrusion so that it's using these three holes that are right here. I'm going to stop sharing my screen for just a second and kind of give a physical view of what that's going to look like from my overhead cameras here. So if I look at my overhead camera, let's see if I can get the exposure down a little bit better. And maybe I should do the side camera instead. See if I can get that to focus. And I'll get its exposure down as well. There we go. So what I'm going to want to try and do is to attach the channel using 3 screws here that are on those end holes of the channel. And what that's going to do is it's going to, first of all, attach the channel very nicely to the extrusion. But secondly, it's not going to want to rotate. So I can be reasonably certain that the channel is perpendicular to the extrusion. Now, obviously, it could be fractions of a degree off, and you might still want to use a T-square or something like that. But at least I'll know that it's there. And if I have another piece of channel on the other end, and I use the same sets of holes, then I'll know that they're parallel to each other. It's going to make a very nice box frame. And by doing that, you know, I end up with a pretty strong frame. It's actually pretty nice. Let me see if I can zoom out here real quick on this to make it a little bit easier to see. So zoom out, zoom out, zoom out. There we go. You know, I ended up with a frame. And so this is just, you know, a pair of extrusions, a pair of pieces of channel, and this thing is really rigid. It's not wanting to move at all, no matter how hard I move it. So that's a nice, good structure to use for the basis of the drivetrain. So I'm back at where I was. So here's the channel, and these are the 3 holes I'm going to attach my extrusion to. Actually, I'm just going to attach to this one and then move it appropriately. So I'll go to Insert, Other Documents, FTC Robotics Parts, Rev Robotics Parts, FTC Structure, Extrusion, Configurable Extrusion. I'm going to choose 420 millimeters because Rev sells the extrusion in that length. Of course, what my team does typically is we buy the meter long and cut it to size. But if you were using one of the kits, you would already have the 420 millimeter extrusion in your kit. And I'm going to grab that into my model. And let's see, did it grab it? There it is, like so. And I'll say, okay, so now I have the extrusion there. And I need to attach the extrusion to the channel. So I'm going to do the same sort of a Fastened Mate that I've done before. And I'm going to go grab that little point that's on the bottom face right in the middle. And I'm going to turn around and go find the channel. Back out, go find the channel. I want to attach it to this point right here on the channel. And so now we can see that it is indeed attached those 2 points together. I'm going to flip the extrusion over because I really want the extrusion to be on that. I have to offset the z-axis by minus 5.5 millimeters so that it is actually on the surface of the channel where the surfaces are mating and not the other. And I'm going to change the Y value to bring the extrusion to the end of this channel. And the channel is 45 millimeters wide. So half of the distance of that is 22.5 millimeters to go in the Y direction. Actually, I'm going to try and do it as 45 millimeters divided by 2 and see what that does. And that worked. Right? So rather than me calculating in my head to say 22.5, I could just literally say half of 45 and it calculated the distance that needed to be there. And so now if I hit OK, now that extrusion is attached to that channel. And it's fixed because the channel is fixed. Another way is I know I'm going to have a piece of channel on the end. So let me go ahead and attach that other piece of channel first, and then I'll attach the second extrusion. So let me go to Other Documents, FTC, Rev, FTC, Structure, Channel, and I want the C channel, but this time I'm going to grab the 88 millimeter C channel here and pull it into the document, like so. And I'm going to attach that piece of C channel to the end of this extrusion, and then I'll attach another extrusion to the other end of that. So let's go do the fasten. So I want to fasten this hole here, like so. I'm going to fasten it to the top face of this piece of extrusion, like so, like so. And again, I need to do the 5.5 millimeter offset bit just to get it to go 5.5 millimeters up. And I'm going to offset it so that it's even with the front of the channel like I did before. So this is 45 divided by 2 millimeters to get it to be even with the front of the channel. And so now I have, we'll zoom out. Now I have this piece in front. And so now if I just take the, and copy and paste the extrusion in. Oh, first of all, let me just go through the step of saying, how far are these holes apart? So I'm going to click this hole and this other hole, and it comes back and it tells me they're 80 millimeters apart. So now when I want to copy and paste the new extrusion in, I can do copy, I can do paste that extrusion, and now I can attach the ends of the extrusions together by doing another fasten operation. So I'm going to fasten this circle here to the other extrusion circle, like so. And I'm going to offset it by 80 millimeters. And again, I chose the 80 millimeters because I measured the distance between this hole and that hole to be 80 millimeters. And so now I can hit OK. And when I zoom out, you'll see that I have that now fastened together. So there I've got one side of my robot done for being able to put the wheels on. Any questions? Comments? So here we are, we're an hour into this and we have already got a frame for our robot, which is, you know, pretty nice. And that's one of the advantages of doing design in CAD is that, you know, you can go through and start to see what your robot's going to look like and begin to look at some of the details that will need to be there or that you want to have available to make it all work. All right, so next is let's put the axles in place for this. And for this particular robot on the 7172 style drivetrains, we very quickly learned in when we built our robot for the Rover Ruckus season, and we were trying to use this style of frame. The typical way that Rev tells and shows for connecting wheels and stuff is by using their brackets. So let me spotlight my video here, right? So typically what they have is they have these items called motion brackets. And so here's a pair of motion brackets. And the idea behind the motion brackets is they act like the pillow blocks do, but that they allow you to extend away from the extrusion a bit more. And not able to get centered on that the way I want, right? And so here's the motion brackets. And then you can take a shaft and you can put the shaft through the motion bracket. This shaft has a bearing on it right here. So you can take the shaft, go through the motion bracket, go through your wheel, go through the other motion bracket that's there, put a bearing on the other side, and I'm not going to bother to do it, but if I could put a collar on the other side, and that's what enables this wheel to be on those motion brackets and enables it to spin. So that's the typical Rev way that has existed for many, many years to do that. But one of the challenges or one of the problems with that is that the motion brackets being made of plastic, they bend a lot. Like if I just take and push on this, in fact, I'm only gonna push on it with one finger, you'll be able to see that I can really make that motion bracket bend a fair bit. And on the other side, I can make it bend as well. And I can even bend them so much that the bushing, the bearing comes out of its socket, right? And so that was just by virtue of bending the brackets. And so if you're using plastic brackets or you're using pieces, you have to be careful about these brackets that they're able to bend. And so you could go to like metal brackets, but Rev doesn't sell metal brackets that would be deep enough for me to get my axle away far enough to be able to put a Mechanum wheel in here. From a 7172 perspective, we like cutting plastic. Plastic is easy for us to cut. Cutting aluminum is a little bit more challenging because we can do it, but it takes a lot longer on the mill that we have. And so we wanted to have a different way of attaching our wheels. And so we switched to using what are called dead axles. And so with a dead axle, what you do, and I'll just flip this around, is you still have an axle connecting the items together, but instead of the axle spinning and there being some sort of bearings in the mounts, you have the axle as being fixed and the wheel turns around the axle. So that's a dead axle. And you can do that fairly easily. It just means that your motion bearings are on your wheel assembly instead of being attached to the axle or being the thing that the axle does. And by using a dead axle, it changes the strength of this structure amazingly well. Because now that the axle is attached to these motion hubs, that Rev has come out with within the last year. The motion hubs can attach to the motion brackets and they have a set screw so that they're attached to the axle. And so the axle doesn't move at all. You don't need a collar because the hubs act like a collar. But once that's in place, this thing is really very, very structurally strong. Like I'm really pushing on it and you can see it barely bends at all. And what you've done is you've made a nice little box structure here, right? So you have things that are fixed here, you have things fixed here, they're at right angles with each other. So you have this really strong structure that's going to hold the axles parallel to the ground and so on. And that becomes really handy for your wheels. And it's really good for Mechanum wheels because you know they're going to stay flat on the ground. So now the challenge to that, the part that becomes tricky, is how do you get the bearings on the Mechanum wheels? For the Mechanum wheels that 7172 uses, that's pretty easy for us to do because we use Nexus wheels in previous seasons, and you can do it with the Go Builder wheels. And we create our own custom hubs for those wheels that, that can contain the bearings. But the Rev Mechanum wheels posed a challenge because the mounting points for the wheels are in this well. They're inside of the wheel down there, and there's not a good place to attach a bearing to go around a shaft. So we ended up making a 3D printed piece to do it. So the end result of that looks something like this. So this is the Rev Mechanum wheel, and it has a 3D printed piece, and depending on how much time we have today, I'll be able to show the modeling of that piece in Onshape CAD here in a little bit. But the wheel has this 3D printed piece on it, and the 3D printed piece then has the bearings inside of the 3D printed piece. So you can see there's the bearing right there, and it has the adapter to be able to hold a hex shaft. And so with that structure, if I put the Mechanum wheel onto a shaft, let's see how long it takes me to get the shaft in here. Oh, good, it just went right on. Now I have the rev wheel, and for it to spin, the axle doesn't have to spin. The axle can stay still, but the wheel will still spin. And because I'm using ball bearings here, it will spin for a good long time, right? I just pressed it once and it's still spinning, and it's now finally getting to the part where it's starting to slow down, right? There's not a lot of friction here, which is also something that you really want to be able to have this work well. So dead axle means that I can get the wheel spinning around the axle itself. And the way that the motors will then drive the wheel is by a sprocket and chain. So the motors will have a chain, and they'll be able to turn the sprocket. Since the sprocket is attached directly to the wheel, when the sprocket turns, the wheel will turn with it. So we've used that design for the past couple of years on our team's robots, and it's worked amazingly well. And the team has already decided they're just building the same drivetrain chassis for the upcoming season. So here's how we're going to put that together in Onshape CAD. So I'm going to start by creating the axle assembly that goes into place here. Since that's a new assembly, and since I'm going to want to repeat it 4 times, I'm going to create it as a separate assembly. I'm not going to put it directly on this frame that I've created. I'm going to create it as a separate assembly, and then I'll be able to duplicate it 4 times really easily. So down at the bottom left, I'm going to share, I'm going to insert a new element. And when I go to insert a new element, it says the different kinds of things that I can create. So I can import a part into my model. I can create a new drawing. I can create a new folder. I can create an assembly, which is what I'm about to do, or I can create a new part. I'm going to create a new assembly. And so now I get a blank assembly that's here, and I'm going to go ahead and rename it. And this is going to be called the axle assembly. And that way I can differentiate it from my other ones. And so for the axle assembly, I'm going to need some basic parts. I'm going to need a motion bracket, an indexable motion bracket. And the only reason I chose the indexable motion bracket is because it's the only bracket in the Rev set of kit of parts that comes for teams that has a big enough distance to get the Mechanum wheel below the tops of the channels. So let me just insert it real quick and we can look at it in the CAD model. So FTC, robot parts, Rev Robotics, FTC, structure, plastic brackets, and the indexable motion bracket is this one, and it's an assembly, so I'm going to pull it in as an assembly. And I'm just going to pull it into my model and say, okay, and we'll look at it. So the indexable motion bracket is actually made of two separate pieces. This piece here is designed to attach to a piece of extrusion. And this piece here then attaches to that first piece, and the rack, the grid that's here, the teeth that are here, lock it in place. So you can have a variable distance from the borehole where your axle is going to go and the extrusion. And that's why it's called an indexable motion bracket. And the distance from this hole to the top of this circle is 32.985 millimeters. I actually know the center to center distance is about 32 millimeters. But the point being that that gets my axle low enough below the frame that the wheel can turn underneath it without hitting anything. Now it's really close. It's only like about 2 millimeters to be able to do it, but it's pretty close to being able to get me what I want. So the first thing I want to do is attach these two pieces together as a unit with this index part at the very top position of the indexable motion bracket. So I'm going to do a fasten. It takes a little bit of thinking to figure out how you want to do a fasten like this. So I'm just going to walk through it to do the fasten because I don't want to spend too much time on it. But what I'm going to do is attach this hole, this hole that's here, to this hole that's here, and then offset the bracket so that it's flush with this face. So let's just start that process. So I'm going to say I want to do a fasten, and I want to fasten the center of this hole, which is that part right there. And I'm going to fasten the center of that hole to the center of this one right there. And so now you can see that they're fastened together, but the bracket is on the wrong side, and that's okay. Now what I'm going to do is offset it in the Z direction. And by offsetting it in the Z direction, I can make it flush with this face. So let's go offset. And I happen to know the thickness of this bracket is 3 millimeters, so I'm just going to offset it 3 millimeters. Again, I could measure that. And then now it is flush with that face. And when I hit the check mark, we'll see that these two brackets are now fixed together. They're fixed together so that the hole lines up and so that the faces are lined up whenever it gets attached to a piece of extrusion. So that looks pretty good. I'm also going to go ahead and fix this piece in my model so that I'm always, so it's not moving around on me. Oh, I probably should turn it too. I don't know if it'll let me turn it while, it won't let me turn it while it's fixed. Let me undo the fixing and let me, oops, I didn't want to undo that part. Let me unfix it. Oh, it's fixed now. Okay, so I'm going to turn this a little bit. So let's turn there. Let's go to the center of this circle here. Let's move this guy to the center of that circle. And I'm going to do a 90-degree turn just so it's upright, a 180-degree turn just so it's upright. And then now I'll fix it in place. That's just going to make it a little bit easier for me to follow what's happening with this model. Okay, so that's one of the indexable motion brackets. I'm going to put the other one and fix it to this one. And I know from my assembly that these two extrusions are 80 millimeters apart. So I'm going to put my brackets 80 millimeters apart as well. So I'll go back to the axle assembly. I'm just going to copy this one. And then I'm going to paste the new one in. And so it pastes it in. And I want to set these two brackets to be 80 millimeters apart. And the main thing for me that I know is I want this hole and this hole have to line up. Those two holes need to be aligned for the axle to go through and be straight. So those are the holes I'm going to join. So I'll do fasten. I'm going to grab this hole, do another fasten, grab that hole, that's good enough. And now I'll do the offset, and in the Z direction, I'm going to offset them by 80 millimeters and then say okay. And now I have my two brackets that are fixed 80 millimeters apart. Let me catch up on some of the questions that are here. So number one, is using a 3D printed piece reliable? I I have qualms with using a 3D printed piece, especially on wheels. But I think on this one, it'll end up being okay. And when we get to the 3D printed part, I'll explain why it'll be okay. But the quick answer to that question is, if I switch back to the view of my wheels here, you'll see that the way this is done is there's a pair of screws that go in through the sprocket into the 3D printed piece. Those screws actually go all the way through the printed piece to the other side, where they're attached with nuts. So it's not as if the sprocket is attached to the 3D printed piece and then the 3D printed piece is attached to the wheel. The sprocket and the wheel are connected by the screws. And so the screws are the part that should be taking the bulk of the torque load that comes from spinning the wheels. So in this case, the 3D printed part is literally acting only as a spacer. It's not, it will carry some of the torque load, but not very much. And if you print it out of something like PLA Plus or a stronger plastic, I think it'll be strong enough. Can you use a dead axle with other wheels as well? Absolutely. That works just fine. Do you need a 3D printed piece if you use GoBuilda Mechanum wheels? GoBuilda has a variety of hubs that they have available that you can use and purchase to make the pieces line up. But then you have to figure out how you're going to get a GoBuilda hub to go onto a Rev axle, or how you're going to take a GoBuilda axle and attach it to Rev parts, or however you want to do it. There's a variety of ways to do that. What 7172 does is we create our own hub plates and we put those on the side out of Delrin plastic. I might be able to bring an example of that when we have a new one built in a couple of weeks. Okay, any other questions before I go to the next part? All right, so I'm going to go ahead and put the axle between these two, and then I'll attach it to the chassis, I think. So to put the axle on here, the next piece I need is one of the locking hubs. So I will go back to the FTC robotics parts, Rev Robotics, FTC motion, rotary motion, bearings and hubs and adapters, and their locking hub is this one here. So I'll go to that, and I'm gonna pull that in. Is it an assembly? It's not an assembly, good. So I'm gonna pull it in to my model, and there it is. I'll close this. And so now I'm going to attach this sprocket hub to the motion bracket. So let's just do fasten. I'll fasten this face, that circle there. I want to fasten to the outside of the bracket right here, like so. And now they are fastened. And I'm going to turn it 90 degrees. And hopefully, maybe, yes, the hole's lined up for me. So I'm just going to leave it at that. Actually, that's a bad 90 degrees. That's a potentially bad 90 degrees. Because what it does, I'll leave it there and then I'll change it here in a second. What that does is it puts the set screw hole on the top. And later when I've put this onto my chassis, that hole may be hard to reach because there may be things above it. It would be much better if the set screw hole was facing a different direction. So I can either go through and turn this component. Actually, I will just turn that component. So let's go, let's cancel that, and let's change the mating on this. And I'll go and do move, and I'm going to change the rotation angle by 120 degrees. And when I do that, now we can see the set screw hole is kind of out the bottom towards the front. And I think that may be a better orientation, easier to reach with a screwdriver or something, because there's not likely to be anything on that side of the robot. Those are the kinds of things that you really want to think about, certainly as you're designing the robot, and more importantly, as you're building it, is to preserve access to the parts that you're going to need to be able to adjust and change later on. It's really easy to design a model in CAD that you can't physically build because you've covered up a screw hole or a nut or something that you need to be able to reach and get together. So I have a locking motion hub here attached to this bracket. I need one more of those. That I'll paste, and I'm going to attach that to the other bracket. For those who are wondering, shouldn't I be making these mirror images of each other? Yes, that's a possible design, but I have a very specific reason for keeping them oriented this way, which will show up on my next step. Let's see, when I put that one in, it's not rotated so that it lines up with the holes. If we look through, we can see that the holes for the hub aren't lined up with this guy. So I should probably fix that mating as well. Again, whether you choose to do this, in your actual model, it's really kind of up to you as a designer to decide how accurate you need your CAD model to be with reality. So I have those both in there, and now I'm going to put an axle between them. And the reason why I've done 80 millimeters and have them oriented this way is because Rev sells, and again, I wanted to stick with Rev parts as much as I could, a 90 millimeter axle. So by sticking with that, I could have a 90 millimeter axle without requiring somebody to go cut a shaft. So let's see, the 90 millimeter one is this one, I suspect. So let me pull it in. Yes, and you'll see that it just fits when I do it this way. If I had turned this around the other way, then the set screws are really on the very edges of the axle, and I didn't want that. So I just kept them this way. And I have plenty of room for the wheel in here anyway, so it'll work out fine. So now I need to join that axle to the hub. So I'm going to join this axle, that end point, to this point inside the hub. If I can grab it. Sometimes in Onshape CAD, you kind of have to move things around to get to the point where you want to join. And so I've done that join, and now I have the axle mounted between the two hubs. Right? So there I've got my structure that I can begin attaching to the model. Okay, any questions on that? I'm going to try and avoid swapping out of sharing screen now so I don't make that mistake anymore. All right, so now let's attach this to our drive frame, our chassis frame. So here's our chassis frame, and I'll go and I'll say insert, and I'm going to go to my current document, the assemblies. I want the axle assembly. I'm going to pull it into my document here and place it there and say that's good. And now I need to join it. So I'm going to join, and I have to do the little extrusion trick, but I'm going to join this circle to the face of the extrusion. So I'll do fasten. I'm going to grab that little point right there that is the center of that hole. And now I'll go back to my extrusion and zip around here. And I'm going to join it onto the extrusion. Again, I kind of have to find the point that I want to attach to here at the bottom of the extrusion. I'm going to grab that point there, and it brings it in. Right now, it only brought that one plate with it. And so let me zoom out a little bit here. It didn't bring the entire assembly. It only brings the one plate. And that is to try and speed up this process a bit, because if you're joining two very complex assemblies and it has to recalculate everything every time you make a little bit of a movement, then this can get really slow and expensive on your computer time. So what they do is they just move the one piece. When I hit the check mark, it'll bring all of the other pieces with it. If I want to see as a preview what it's going to look like, I can hit the solve button, and that just says, okay, do the whole thing real quick. And now it brings the other piece with it. But I want to make some adjustments here so that we're also not in the middle of the extrusion, and so that this axle is back a ways from the front of the robot. So I'm going to do the offset bit here. My Z-axis, I know I need to go minus 5.5 millimeters to get that out on the surface. And in my X direction, I'm going to go minus 42 millimeters. And that puts the bracket somewhere back there, right? And those are just numbers that I picked out. And so now I've got my axle set up and attached to the frame. And if I want to attach another one, I can just copy the axle assembly and paste it in. And now I'll have another one. And I can paste that one in onto the back of the robot. So let's do that real quick. So I'm just going to do the same set of steps. I'm going to say do a fasten, grab that hole and move it around to here and do a fasten here and grab this part there. If I can grab it, there we go. And I want that part there. So it brought it there for me. I know that I need to offset by minus 5.5 millimeters. And in the X direction, I'm going to go by 42 millimeters this time. And let me just do that. And so now it's moved the bracket to be approximately the same place where I had it before. And I'll hit OK. And now I have the other axle on the robot. So we're getting pretty close. We're getting quite a ways along. Any questions on those steps that I just did? All right. So now let's add the sprocket and the hub bit that we need for attaching the Mechanum wheels. So hey everybody, it's Patrick. As I was post-processing the video from Saturday morning to prepare it for being posted on YouTube, the next part of the video goes into the design of the 3D printed spacer to attach the sprockets to the Mechanum wheels from Rev. And I decided that that would be better off done as its own separate video, which I'll reshoot here in a little bit. But I wanted to go ahead and get the existing part of the video up on the web. So we will end the clinic here for the web version and be watching for the follow-on video that describes how the spacer is created and how it gets integrated into the model in another video coming up really soon. Thank you for watching, and be looking for our new video, and we hope to see you again soon.